Alright guys, you just watched a video about what is a factor. So now we're going to go over how to find the greatest common factor. Now there are two methods of doing this. The first method is to use prime factorization. So just a reminder, a prime number is a number that can only be divided by itself and 1. So we're going to look at two numbers. We're going to look at the number 36. We're going to look at the number 54. So the first thing we're going to do is we're going to break these numbers down into their prime factors. So starting with 36, we need to find two numbers that multiply to equal 36. So probably two numbers that jumped right to your mind were 6 times 6, because 6 times 6 is 36. Now 6 is not prime, therefore we have to keep going. 6 can be multiplied, so we can divide 6 up into 2 times 3. 2 is a prime number. 3 is also a prime number. So we've found two prime numbers that go into 36. So now we're going to break this 6 up into its prime factors, and those would also be 2 times 3. So we now have all four of our prime numbers. So 36 ends up being 2 times 3 times 2 times 3. Now we're going to work on 54. So this one might not have anything that immediately jumps to your mind as quickly as 36 does, but because 54 is even, I know that 2 can go into 54. And if you divide 2 into 54, you get 27. Now, 2 is a prime number. 27 is not, so I must continue making my branches to get more prime numbers. So 27 can be divided by 3. 3 goes into 27 9 times. Again, 3 is prime, but 9 is not. So your trees can keep going until you get all the prime numbers. So 9 can be broken down into 3 times 3. And finally, we have all the prime numbers that make up 54. So what this means is if I was to multiply 2 times 3 times 3 times 3, this would multiply to equal 54. So now, down here, we're going to write down that 36 is made up of 2 times 2 times 3 times 3, or you might sometimes see this as 2 squared times 3 squared. 54 is made up of 2 times 3 times 3 times 3, or again, you might see this as 2 times 3 to the third. So what we need to do now is we need to find the factors they have in common. So you have to have the exact same factor in each number. So for example, these 2's right here are a common factor. These 3's are a common factor. These 3's are a common factor. However, the 2 and the 3 that are sitting right here, these are not common factors because they don't have a pair to match with. So our greatest common factor here, the shared factors, are going to be 2 times 3 times 3. And you can see this in the exponents because 2 to the second and 2 to the first have 1 2 in common. 3 to the second and 3 to the third have 2 3's in common. So now all we have to do to find our greatest common factor, so we call that our GCF, is multiply 2 times 3 times 3. So 2 times 3 times 3 is going to be 18. So our greatest common factor, the biggest number that divides evenly into both of these numbers, 36 and 54, is 18. So now let's look at a problem that has variables. So we're going to have 8x squared y and 24x to the third y. So the first thing we want to do is we want to look at the numbers. So we're going to completely disregard the variables for the moment, and we're going to prime factor out the number 8. So 8 factors out into 2 times 4. 2 is prime. 4 is not. So 4 factors down into 2 times 2, because 2 times 2 is 4. So we now have our prime factors of 8. We're going to do the same thing with 24. So 24, there's lots of ways you can start. You can start with 2 times 12, 3 times 4, 3 times 8, 4 times 6. Any of those we can start with. So I'm going to start with 4 times 6. Now 4 is not prime, so that breaks down to 2 times 2. And 2 are both prime. So now I'm going to go over to my 6. 6 is made up of 2 times 3. And 2 and 3 are now both prime. So 24 is 2 times 2 times 2 times 3. So 8x squared y factors down into 2 times 2 times 2. But we also have to consider the fact that there's x's here. So x squared just means x times x. Y would just be times y. Our 24x to the third y breaks down into the factors 2 times 2 times 2 times 3. Then there's 3 x's because I have x cubed. Whoops. And 1 y. So now I have all the prime factors of 8x squared y and 24x cubed y. So now we're going to start looking for shared factors. So we have a factor here that's shared. We have a factor here that's shared. This factor is shared. Okay, so automatically we can see our GCF is going to be made up of 2 times 2 times 2. Or 2 cubed. Now there's not a 3 in common, so now we're going to look at our variables. So this x can be paired up with this x can be paired up with this x. So we have 2 shared x's, so times x times x. This x doesn't have a matched x on 8x squared y, so now we're going to look at our y's, and they have 1 y in common. So times y. So these are all the factors that are shared, which means our greatest common factor is going to be 2 times 2 times 2, which is 8. X times x is x squared, and then y. So these are our greatest common factors. Now, the second method, I use this one a little bit more, is where you list all the factors of each term. So for example, looking back at 18, and let's do 27. So 18 and 27 are going to be the two numbers we use. We are going to list down all the factor pairs of these numbers. So starting with 18, I always start with the number 1. 1 times 18 is 18. Then I'm going to try the number 2. 2 times 9 is 18. Alright, so now we have 4 factor pairs. I'm going to do 3 times 6 is 18. Now 4 does not divide evenly into 18. So I'm not going to put 4 down. I'm going to look at 5. 5 does not divide evenly into 18. So when I get to 6, 6 goes into 18 3 times, but notice I already have this 6 right here. So I don't need to rewrite it. So once you get to that turnaround point, so notice right here it turned around, you know you have all your factors. So now we're going to try 27. Start with 1. 1 times 27. 2 doesn't go into 27. This is not an even number. 3 goes into 27 9 times. 4 doesn't divide into 27. 5 doesn't go into 27. 6 does not divide evenly into 27. Neither does 7 or 8. So now we've gotten back to our 9. So I know I've got all my factor pairs. So now I'm going to look and see what factor pairs they have in common. So we have a 1 in common. We have a 3 in common. We have a 9 in common. So we're going to write those down. We have 1, 3, and 9 that they have in common. But we're looking for the greatest factor. So the largest factor that they have in common is going to be 9. So that's going to be our GCF. Our greatest common factor is 9. So it's the same way with our variables. So if we did 15 x squared y squared, and if we did 4xy squared. So we're going to list out all our factor pairs of 15. So 1 times 15, 2 doesn't go in. 3 times 5, 4 doesn't go in. I've gotten to my turnaround point, so I know I have all the factors of 15. Now I'm going to do the same thing with my x's. List out all my x's. So x times x, and I have y times y. So I've also broken down x squared and y squared. So now 4, the factors of 4 are 1 times 4 and 2 times 2. Notice I've gotten to my turnaround point, so I know I'm done. My factors of x are x, and my factors of y squared are y times y. So now we need to find the highest factor. So if we look here, the biggest factor they have in common, we have 1 in common, and that's the only thing we have in common. So sometimes 1 is the greatest common factor. But notice we also have an x in common, and we have 2 y's in common. That's the most we have in common. So our in common is going to be 1 x and y squared. So when we put this all together, our greatest common factor is 1 x y squared. And if you want to put the 1, you can, but you don't have to. So there's our greatest common factor. Now again, you can use either method, listing factors or factor trees. Now usually I don't use a factor tree unless it's a very large number. Most of the time listing factors is a little bit quicker.